अच्छा, so I think we did enthalpy of combustion, right? वो हमने कर लिया था. So there were two more enthalpy changes which were left. The one was the delta HN. ठीक है, मतलब क्या था standard enthalpy change of neutralization. ठीक है, that's delta HN. और वो क्या था? It's also always an exothermic process. ठीक है, तो always exo. And what was it? It's energy release क्योंकि it's always exo. Or energy change when what happens when 1 mole of क्या होती थी डेफिनेशन? इसको पता है किसी को? आला मावा, व्हाट्स द डेफिनेशन?
The energy released when 1 mole of acid reacts with 1 mole of alkali to form water and salt.
हाँ, लेकिन it's not 1 mole of acid and 1 mole of water. बाकी सही है, बिल्कुल सही है. It's when 1 mole of water is produced
from the reaction between an acid and an alkali under standard conditions.
ठीक है, so 1 mole of water is produced when and अच्छा, acid और alkali के moles जो मर्जी हो, ठीक है, they don't, so they could be more than one. When an acid and alkali react under standard conditions. So ठीक है, that's what delta HN is. ठीक है, so for example, आपके पास you've got NaOH and you've got sulfuric acid and they're reacting and they produce sodium sulfate and they produce water. और इसको balance कर लो. मुझे था वो is the enthalpy change of this reaction delta HN? ये है कि नहीं है? but इसमें issue क्या है? Acid and alkali are reacting but it's not 1 mole of water that's getting produced. So अगर मैं if I divide the whole equation by 2, ठीक है, if I do that, now the enthalpy change of this reaction would be delta HN. Is that clear?
Yes, sir. It's clear.
अच्छा, फिर ये कि delta HN normally always has the same value. No matter what the acid, what the base is. मतलब pure acid भी हो ना, अगर let's say if I have KOH and I've got uh, कोई आम सा acid HNO3 कर लेते हैं. And they're giving me KNO3 plus H2O. अच्छा, anyways, you've got this reaction और इसमें क्या है कि इसका जो ये भी delta HN है, 1 mole of water is getting produced. ठीक है, that's important. Now, the other important thing is delta HN always has the same value, no matter what the acid, what the base is. So generally, what happens is delta HN for strong acids and strong bases is always the same. So which is what it's always the same, which is approximately equal to delta HN, approximately equal to minus 57 kilojoules per mole. And the reason it's always the same is because it's always the same ionic equation. हर दफा एक ही चीज हो रही है. एसिड क्या करता है? एसिड जो है वो H+ आयंस प्रोड्यूस करता है and the alkali produces OH ends, and the two react together, and you get H2O. So it doesn't really matter where the acid is coming from, where the OH ends are coming from. The end result is the same bonds are going to be formed. So it's always the same ionic equation, which is why you get the same energy change. ठीक है? ये clear है?
Yes, sir.
और फिर इसमें exception ये है कि for weak acids or alkalis, this value is slightly less exothermic. My example होगा कि delta HN would be minus 53. ठीक है? Per mole. ठीक है? अच्छा, the reason is it's slightly less exothermic as some energy gets used. वो थोड़ा सा endothermic हो जाता है. Some energy is needed for what? It's needed for ionization या dissociation. क्योंकि वो जो एसिड है ना उसके बॉन्ड्स, वो जो H प्लस वन आयंस है ना, इशू ये कि वो जो H प्लस वन आयंस है वो H प्लस वन आयंस produce नहीं हो रहे. The acid is unable to produce the H plus ions. So you need some energy to break or produce those H plus ions in the first place. ठीक है? So which is why it's slightly less exothermic. ठीक है? ये भी clear है?
जी सर.
अच्छा चलो, ये हो गए चार, तीन हुए एक्चुअली. बॉन्ड एनर्जीज भी हो गई थी. फोर्थ वन जो था ना वो थोड़ा जेनेरिक सा था. दैट वाज इसमें और तो कुछ नहीं है एसिड्स में, बस यही है. हाँ, थोड़ा सा वो पता होना चाहिए कि which ones are weak acids, which ones are strong acids. So I'm just going to strong acids जो है ना, they're mostly your mineral acids. Mineral acids में आ जाते हैं your HCls, your nitric acids, your sulfuric acids, etc. अच्छा, weak acids में कौन होते हैं? Weak acids में you've got your organic acids. ठीक है, so weak acids you've got your, one second. अच्छा, weak acids में you've got your organic acids. और organic acids में कि for example you've got your RCOOH. ठीक है, अभी आगे जाके जब organic पढ़ेंगे तो there's going to be more acids which we're going to study apart from the normal carboxylic acids. अच्छा, and then you have another type of acid which is known as your acid salts. ठीक है, तो acid salts tend to be weak acids as well. अब acid salts, hala Mawa, you know what acid salts are?
No, sir.
उसका मैं थोड़ा सा आइडिया दे देता हूँ कि व्हाट्स एन एसिड सॉल्ट. कि इसको थोड़ा सा एक्सप्लेन कर लेते हैं. ये आगे जाके ना एक पूरा चैप्टर होगा जिसका ना we'll discuss those in way more detail. But अब जैसे सल्फ्यूरिक एसिड है ना, ठीक है, that's a diprotic acid. That means कि it's got, अगर ये रिलीज करेगा ना तो it's going to produce two H plus ions. लेकिन वो ना H plus ions इकट्ठे, it's not going to produce all those H plus ions in one go. वो क्या करेगा? It's going to produce one H plus ion, and what you'll get is HSO4 minus one. ठीक है, और फिर let's say एक और collision होती है, and then that HSO4 minus one, it ends up producing another H plus ion, right? ये आइडिया क्लियर है कि there's a diprotic acid और वो दो steps में या दो reactions में या दो collisions में it ends up producing H plus one ions. First the first one breaks off, फिर वो जो एक रह गया ना पीछे, then that breaks off. ठीक है, and you're left with the SO4 minus 2 ion. क्लियर है ये?
Yes, sir. It's clear.
अच्छा, तो अब इसको देखो. The first H plus ion, okay, it breaks off from a neutral molecule, right? The H plus one breaks off, leaving behind you this thing. I said, like, if you look at the second H plus one breaking off, now it's a negative ion. And the negative ion releases an H plus ion, okay? So, मुझे बताओ कि which of these steps is going to be more difficult? Is it going to be difficult for the neutral molecule to produce an H plus ion? Or is it going to be more difficult for a negative ion to produce an H plus one ion? Basically, guess karo, hala, Mama, what's for which one releasing an H plus one is going to be very difficult?
The HSO4 ion?
Yeah, or I say it's a negative ion, right? So
Yes.
negative ion ko issue ye hai कि negative ion isn't supposed to release an H plus one. It's supposed to attract an H plus one. Negative ions, they attract positive ions. Okay. So the issue is कि it's a negative ion and it's going to attract H plus one ions, right? So why would it release H plus ions? So hence, there's going to be less dissociation. It would be very hard for it to actually. So it's going to be very hard for it to actually let go of H plus one ions. ये clear है? Mawa clear है? Hala, is this clear?
Yes, sir.
Yes, sir, it's clear.
तो होता ही है कि when you have a diprotic acid like sulfuric acid, although it's considered a strong acid, but it's only a strong acid when it comes to the first dissociation. When it comes to the second dissociation, it actually becomes a very weak acid. क्योंकि अब वो खुद negative हो चुका है and it will be attracting H plus one. So it would be very hard for it to actually produce more H plus one ions, right? Or similarly, there's another triprotic acid like triprotic concept of phosphoric acid, right? So there's another one which is triprotic acid. A phosphoric acid, जो है ना, it's capable. It's also considered a strong acid, and it's capable of releasing 3H plus ions. Like it's not going to do that in one go, ठीक है? तो पहले तो वो एक प्रोड्यूस किया, फिर अब दो बच गए, ठीक है? So you've got H2PO4 minus one. Now it's going to produce another one, and you will have HPO4 minus 2 ion. So now the HPO4 minus 2 ion, there's one H left. So that will produce another H plus ion. So 3 steps, man. So the first one would be strong, neutral molecular. It's going to release an H plus ion. This is going to be weak. And the last one is going to be very, very weak. आखिरी वाला जो है ना वो तो H plus one प्रोड्यूस करेगा ही नहीं. -2 चार्ज है, वो तो अट्रैक्ट करेगा, उसके लिए तो it would be very hard and very difficult for it to lose another H plus one ion, ठीक है? तो ये क्लियर है?
Yes, sir.
अच्छा, so the thing is acid salts, ना? So any salt that has this ion in it, ठीक है? That's what an acid salt is. So any salt that's got this ion in it, वो एक weak acid होगा, ठीक है? It's going to be a weak acid. So these are part of acid salts. मैं बता देता हूँ acid salt क्या होता है. For example, you've got NaHSO4, right? So Na is +1, HSO4 is -1, right? So it's like a मतलब वो acid completely salt नहीं बना, ठीक है? It's something in between. Like there's still H plus ions left, but it would be very hard for those H plus ions to be produced because it's a negative ion. ठीक है उसी तरह these ions will be part of acid salts. It's a negative ion, so it's going to be Na plus 1 and H2PO4 minus 1. या फिर वो नीचे वाला it's going to be Na plus 1 तो Na twice हो जाएगा and HPO4 minus 2, right? So these are acid salts and they produce very few H plus ions. They don't dissociate. They are weak acids. Clear बात सारी acid salts वाली.
Yes, sir.
बाबा ठीक है. इधर मैं add कर रहा हूँ acid salts क्या होते हैं when an acid gets partially neutralized. ठीक है that's what it is. ठीक है. अच्छा basis पे भी आ जाते हैं. बल्कि alkenes पे strong alkenes. ठीक है. So you've got strong alkenes जो कि normally आपकी ना group 1 hydroxides. ठीक है. So you've got group 1 hydroxides. For example, NaOH, KOH, some group 2 hydroxides, those at the bottom. ठीक है, the bottom ones. क्योंकि वहां पे if you know the solubility table, those were the ones that were soluble. तो उसमें ना you've got कौन सा होंगे group 2 bottom वाले barium hydroxide and I've got strontium hydroxide as well. एक ammonium hydroxide है, that's also. अच्छा और फिर वो आ जाते हैं weak alkenes पे. You can remember alkenes were the ones that were soluble. अच्छा weak alkenes are not going to dissociate that much. तो उसमें number 1 जो है that's ammonia. Ammonia NH3 ठीक है, that's considered a weak alkali. और amines भी वो खैर organic का part है. ठीक है, amines are basically molecules that have carbon chains and they've got NH2 attached to it. ठीक है, तो आपको आइडिया होना चाहिए which one is a strong alkali, which one is a weak alkali. Weak alkali में दिमाग में बिठा लो कि नाइट्रोजन वाली जो alkalis हैं they're all weak alkalis. ठीक है, तो यहाँ तक क्लियर है सारा.
Yes, sir.
अभी तक हम A2 तक नहीं पहुंचे. ये कुछ चीजें ना वो थोड़ी सी AS से थोड़ी सी एडवांस हो गई. एसिड सॉल्ट आई गेस AS का पार्ट उस तरह नहीं था, लेकिन ब्रीफ से इंट्रोडक्शन हो गया एसिड सॉल्ट का. अच्छा मूविंग ऑन, you've got एक एक और definition है which isn't really that important and that's standard enthalpy change of reaction. ठीक है, that's your delta HR. अच्छा delta HR is अच्छा delta HR is the energy change of a reaction when stoichiometric quantity of reactants are used and products are produced. As described by the equation. ठीक है, measured under, अच्छा, measured under standard conditions. अच्छा, इसका क्या मतलब है कि इसका बस मतलब ये कि अगर कोई रिएक्शन है ना and it's got an enthalpy change, any reaction, if it's got an enthalpy change, then that energy change would be labeled as delta HR. But only के कब वो label होगा? It's going to only get labeled अगर 1 mole nitrogen जो है ना वो 3 moles hydrogen के साथ react करें and they're producing 2 moles of ammonia. ठीक है, तो कोई अगर आपसे डेल्टा एच आर मांगता है ना, तो दैट मीन्स कि जो इक्वेशन में मोल्स लिखे हुए ना वो एग्जैक्टली ही इज आस्किंग फॉर द एंथैल्पी चेंज ऑफ दोस पर्टिकुलर मोल्स. बेशक आपने रिएक्शन में 10 मोल्स इंट्रोड्यूस किए हैं, ही इज नॉट आस्किंग फॉर द एनर्जी चेंज व्हेन यू रिएक्ट 10 moles of nitrogen or you react 30 moles or 5000 moles or 0.1 moles. जब वो डेल्टा एच आर मांग रहे हैं ना, वो मांग रहे हैं कि अगर 1 N2 होता ना और उसके साथ they were 3H2 reacting and they were producing 2NH3, he's exactly asking for the enthalpy change of that particular quantity of reactants reacting and products getting produced. ठीक है, चलिए हाला और मावा, ये क्लियर है ये वाला पार्ट?
जी सर, क्लियर।
चले अब हम आहिस्ता आहिस्ता मूव करें नेक्स्ट डेफिनेशन है, that's A levels. ठीक है, नेक्स्ट वाली that's A levels and that's going to be the standard lattice energy or simply lattice energy. निकाल लेते हैं बल्कि वर्ड स्टैंडर्ड. अच्छा, वो पिछली वाली जो डेफिनेशंस थी ना वो तो सारी पहले से की हुई. स्टैंडर्ड लैटिस एनर्जी दैट्स नोन एज, इसको इस तरह लिखा होगा डेल्टा एच एल ई, एंड दिस इज वेरी स्पेसिफिक. इट्स फर्स्टली इट्स एक्सोथर्मिक ऑलवेज. मैं इसकी ना वैल्यूज भी बता देता हूँ. -500 से ना -1000 वाली रेंज है. जी, -1000 नहीं, to minus let's say 5000. अच्छा, the range is important, and the reason the range is important is क्योंकि इस पे you'll be asked to do a lot of calculations. और मतलब अगर आपको आपकी वैल्यू आ रही है, आंसर आ रहा है -20,000, तो ये काइंड ऑफ श्योर कि आपका आंसर गलत है, क्यों आपको पता है उस रेंज से बाहर निकल गया ना. तो यू शुड डाउट कि यू मस्ट हैव मेड सम एरर्स इन योर कैलकुलेशन. अगर वैल्यू -200 आ रही है तो भी देयर इज अ वेरी ब्राइट चांस कि जो भी कैलकुलेशन किया ना वो आंसर गलत है. सो रिमेम्बरिंग द रेंज इज काइंड ऑफ इम्पोर्टेंट. ठीक है, और मैं वो थोड़ा सा वो भी बता दूंगा रेंज हायर साइड पे कब होगी, लोअर साइड पे कब होगी, सो दैट विल आल्सो काइंड ऑफ, आई मीन इट्स काइंड ऑफ अ डबल चेक कि यू विल बी एबल टू फिगर आउट कि कैलकुलेटर ने जो भी आंसर दिया ना उसका एक चेक लग जाएगा कि यू कैन सी के कोई गलती तो नहीं की. अच्छा, सो व्हाट इज लैटिस एनर्जी? लैटिस एनर्जी इज कि इट्स द एनर्जी फॉर फॉर्मिंग अ लैटिस. ठीक है, तो डेफिनेशन इज इंपॉर्टेंट. इट्स द एनर्जी दैट इज रिलीज्ड, और ये हमेशा आयनिक कंपाउंड्स के लिए होगी. सो दिस डेफिनेशन इज ओनली फॉर आयोनिक. अच्छा, so it's what? It's the energy that's going to be released when what happens? When 1 mole of solid ionic lattice is formed. From what? From its ions, from its constituent. Gaseous ions. ठीक है, measured under standard conditions. अच्छा, measured under standard conditions. So what is it? It's हो क्या रहा है इसमें? It's if you want to form NaCl solid, so it's going to be formed from its constituent gaseous ions. The gaseous ions are sodium ions and the other one is Cl ions, and both of them are gaseous. तो इसकी जो ये 1 mole होना चाहिए, ठीक है? This has to be, you need to form 1 mole of lattice, ठीक है? And the reason it's exothermic is ionic bonds are getting formed. So hence it is going to be exothermic. ठीक है, Mawa, hala, is this clear?
Yes, sir.
और इसको ना इमेजिन कर लो कि you've got इसको इमेजिन करो भी ढेर सारे Na+1 Cl ions सारे ना अलग अलग घूम रहे थे, ठीक है? They were flying around, ठीक है? They were not bonded to anything. So they were just randomly, haphazardly moving in different directions. And then they ended up attracting each other. And when they ended up attracting each other, they started to strongly attract each other and they started bonding or binding it themselves together, sticking to each other. And they end up forming this ionic crystal, okay? So it was bond formation only, and that's what lattice energy is. Okay? So that's what lattice energy is. Now, lattice energy, if you have a strong lattice, like a really strong lattice, so if it's a strong ionic lattice, then your delta HLE is going to be more exothermic. ठीक है, stronger bonds बन रहे होंगे तो वो ज्यादा exothermic होगा. Right? Is this clear? मावा हालांकि ये clear है?
Yes, sir.
जितने strong bonds.
Yes,
अब
sir.
मुझे बताओ तो basically एनर्जी रिलीज होनी है, आयोनिक क्रिस्टल या आयोनिक लैटिस फॉर्म होगा, आयंस एक दूसरे के साथ बाइंड करेंगे, they'll have strong electrostatic attraction and they'll join together and they're going to release a certain amount of energy. ठीक है, उसकी रेंज भी मैंने बता दी, it's -500 to 5000 if it's a very strong ionic lattice. And remember, ionic lattice, they tend to be really strong. ठीक है, ionic lattices अगर उनकी प्रॉपर्टी वगैरह पता है कि they tend to be extremely strong. आपका जितना भी limestone, marble, even cement, concrete वगैरह, ठीक है, they're all ionic compounds. They're all a bunch of ions sticking together. Magnesium oxide refractory materials like magnesium oxide, they're known to be one of the hardest substances on the planet. ठीक है, तो वो तो heat shields और उसमें भी लगता है, ठीक है. And the crystal does not break. They're very brittle, but they don't break. They're very strong, and plus some marble है, it could last for 30 years. I mean, it is brittle, but it could last for 30, 40 years. ठीक है, concrete है. It's also brittle, but it could be, I mean, it could last for centuries. ठीक है. तो अब मुझे बताओ कि आयनिक पता कैसा लगेगा आयनिक लैटिस स्ट्रांग है या वीक है? What does the strength of the ionic lattice depend on? हाल any idea?
Their lattice energy?
नहीं, वो लैटिस एनर्जी तो ज्यादा होगी ना, लैटिस स्ट्रांग मैं तो वो कह रहा हूँ. ये पता कैसा लगेगा लैटिस स्ट्रांग? इट्स मैग्नीशियम ऑक्साइड इज लाइक रियली स्ट्रांग, राइट? लेकिन जो टेबल सॉल्ट है दैट्स अ वेरी वीक लैटिस, NaCl है. तो दोनों में क्या फर्क है? मतलब व्हाई इज मैग्नीशियम ऑक्साइड सो
The,
स्ट्रांग?
the amount of electrons bonded, magnesium oxide has two, and sodium chloride only has one pair shared.
नहीं, इलेक्ट्रॉन से चार्ज होगा ना.
Yeah.
ठीक है, नंबर वन इज द चार्ज ऑन द आयन. क्योंकि जैसा मैग्नीशियम ऑक्साइड है तो मैग्नीशियम ऑक्साइड इज is Mg plus 2 attracting oxygen minus 2, right? Versus Na plus 1 attracting Cl minus 1, right? So obviously Na और Cl के बीच में attraction कम होगी because the charge is very less. ठीक है, तो greater charge on ion, that would need to more electrostatic attraction. Stronger ionic bonds, ठीक है? तो strength of ionic lattice depends on the charge on the ion. तो ये clear है?
Yes, sir.
एक और factor भी जिस पर depend करता है वो,
Ionic radius?
yeah, that's ionic radius, right? Because I told you earlier as well कि the smaller atom is the one, or the smaller ion is the one that's going to make the stronger bonds, ठीक है? So the second factor is happens to be the ionic radius. ठीक है, अच्छा तो उसमें क्या है कि smaller ions, they're more tightly packed, they're closer to each other, so that leads to more attraction. Smaller ions have greater charge density, which leads to more attraction. चलिए ठीक है, क्लियर है यहाँ तक?
Yes, sir.
तो ये याद है आयनिक लैटिस था, वो प्रेडिक्ट करने को एक वो क्वेश्चन भी देते हैं कि फॉर एग्जांपल you've got NaCl and you've got KCl, right? So which one is the stronger lattice? It's this one is the one that's going to be stronger, ये जो जिसके छोटे आयन्स होंगे. Na is smaller, K is bigger in size. ठीक है, तो इस तरह के बहुत सारे 2-3 मार्क के क्वेश्चन आएंगे, वो पूछेगा भी रीजन कि मैग्नीशियम ऑक्साइड स्ट्रॉन्गर है, उसकी लैटिस एंथैल्पी ज्यादा है या NaCl की ज्यादा है, NaCl की ज्यादा है या फिर KCl की ज्यादा है. तो चलो ठीक है, कल कंटिन्यू करते हैं, ठीक है?
Okay,
sir. Allah Hafiz.
चलो, ओके, टेक केयर एवरीवन, लव.